All right, section 5.1, the product rule and power rules for exponents. All right, a number is said to be written in exponential form if it is written this way, where A is the base and M is the exponent. And the exponent tells you the number of times to multiply the base times itself. For example, 2 to the third power means that you're going to multiply 2 times itself 3 times. And 2 times 2 times 2 is 8. All right, so we want to write 3 times 3 times 3 times 3 times 3 in exponential form and evaluate. All right, so we have a total of 5 3s, so that'll be 3 to the 5th power. And if you multiply 3 times itself 5 times, you get 243. All right, we want to identify the base and the exponent of each expression and then evaluate. All right, so the first one is 5 to the 4th power. The base would be 5, and the exponent would be 4, and 5 to the 4th power would be 5 times itself 4 times is 625. All right, now when you add a negative in there, keep in mind that the exponent only applies to what is immediately in front of it. So in this case, the base is still just 5 and the exponent is 4. But when you evaluate it, you're going to carry that negative over into your answer. So that would equal a negative 625. All right, but if I put the negative 5 in parentheses, in this case, the 4 or the exponent applies to the whole quantity. So your base is negative 5 and the exponent is still 4. And whenever your exponent is even and you have a negative inside your parentheses, that will evaluate to a positive. So that will equal a positive 625. That was part C. All right, and then let's do one more. Negative 5 to the 3rd power. In this case, again, since it's in parentheses, your base is negative 5. Your exponent is 3. And since the exponent is odd and we have a negative, that's going to evaluate to a negative. So that will equal a negative 125. All right, so here are the rules or the rules for exponents. And we'll start with MADS. M-A-D-S. That's just going to be a way for you to remember the rules. All right, so if we are multiplying exponents of like bases, we add. So that you keep the base the same and you add the exponent. So a to the m times a to the n is equal to a to the m plus n. So that's where the m and a come from in MADS. When you multiply, you add. All right, when you are dividing exponents of like bases, you subtract. So that's where the ds comes from in math. So a to the m over a to the n is equal to a to the m minus n. All right, so we want to use the product rule for exponents to simplify each expression. All right, that's going to be the MA of math. So 6 to the third times 6 to the fifth. The bases are the same. So we're going to keep that same base, 6, and add the exponent. So that'll be 6 to the 3 plus 5, which is equal to 6 to the 8th. Now, we could multiply 6 times itself 8 times, but that's going to be a really big number. So you can just stop at 6 to the 8th. All right, negative 4 to the 7th times negative 4 to the 2nd. Of course, you keep that base the same and you add those exponents. So that would be negative 4 to the 9th. All right, x to the 2nd times x. All right, this x does not have an exponent, but it's an assumed 1. So that is the same as x to the 1st power. So that would be x to the 2 plus 1 is x to the 3rd power. All right, here we have like bases. So we're going to add the exponents. So m to the 4 plus 3 plus 5 would be m to the 12th. All right, this one, we have unlike bases. So we're going to simplify them individually. So 2 to the 3rd power is 8. 3 to the 2nd power is 9. And 8 times 9 is 72.